Looking at a fractional equation now. A fractional equation is an equation with fractions in it. And we have kind of seen this before, but what we're seeing now is equations that are going to have rational expressions in them, something like this 3 over 2x over here. Now the basic structure, basic protocol of solving a fractional equation, the basic steps are going to be to multiply each term by the least common denominator, which is decided upon by you. Reduce before you do any multiplication, and the denominators should divide out here, right? And what's left, you're going to multiply together. And you should get a fraction, you should get an equation with no fractions in them. Check your answers is the last step, right? And this is important because it is possible that we are going to reject some answers, and we will see some examples of that. Now, real quick, just multiplying fractions. We covered complex fractions, so we know how they are going to work. A over B over C over D is going to equal A over B times D over C, keep, change, flip. A times B over C you're going to see much more often, which is just multiplying fractions together, okay? So let's take a look at number 1 here. Solving and checking 3 over 2x minus 6 over 5 plus 2. Right? We have a least common denominator between 2x and 5. Our LCD is going to be 10x. So here's what we're going to do. We're going to take 3 over 2x times 10x minus 6 over 5 times 10x plus 2 times 10x equals 0 times 10x. We're taking every single term in this fractional equation. We are multiplying that each term by this LCD. We are multiplying the LCD on top only. This is not what you do with fractions. This is what you do with equations, right? Again, this is an equation, which means that we are allowed to multiply only the numerators as long as we are multiplying each and every term in this equation by the same thing, in this case 10x. All right, so take a look at what happens here. 2x over 10x divides out to be 5. 5 over 10x divides out to be 2x. So this is what our equation looks like. Nothing else is going to reduce here and here. We're going to get 3 times 5 minus 6 times 2x plus 2 times 10x equals 0 times 10x. All right, so we have all this multiplication to do, but all this multiplication, there's no denominator. These are not fractions anymore. These are just whole numbers. They're just regular rational, regular algebraic expressions, but not fractions. 15 minus 12x plus 20x equals 0. And this is the equation that we have left to solve. So before we solve this, let's go back. Multiply each term by the LCD. That was what we did here. Reduce. And reducing really kind of meant this part here, right? We are reducing on each level of multiplication. Now what we're going to do is multiply what's left, right? That is over here. And we did that. We got 15 minus 12x plus 20x equals 0. And now we have to solve our equation. So 15 plus 8x is equal to 0. Subtract 15 from both sides. 8x is equal to negative 15. Divide by 8, and x is equal to negative 15 over 8. Now, in order to make sure that this answer is good, we're going to check our answer in our original equation. That is 3 over 2 times negative 15 over 8 minus 6 over 5 plus 2 is equal to 0. Again, checking means evaluation. We're going to check the left side of this to make sure that it adds up to 0. So that's going to be 3 over negative 30 over 8 minus 6 over 5 plus 2 equals 0. We have a complex fraction. That's going to be 3 over 1 times 8 over negative 30 minus 6 over 5 plus 2. I did keep change flip at the same time, which means I flipped this fraction on bottom. We can reduce this to make our multiplication life a little bit easier. So that's going to be negative 8 over 10 minus 6 over 5 plus 2. So negative 8 over 10 minus 12 over 10 plus 20 over 10, we need a common denominator. And that common denominator is going to be 10. So negative 8 minus 12 is equal to negative 20 over 10 plus 20 over 10. And this adds up to 0, which means that the left side and the right side match up. And this answer is good. So let's go ahead and add a new page so that we have some room to work with. And we'll take this number 2, cut it, paste it here. So let's work with a full fresh page. Denominator is 3, 6, and 2. That means our LCD is going to be equal to 6. X minus 6 over 3 times 6 minus x plus 2 over 6 times 6 equals 1 over 2 times 6. Cancel this out. 6 and 6 cancels. 3 and 6 reduces to 2 up top. 6 and 2 reduces to 3 up top. Once again, 2 times x minus 6 minus x plus 2 equals 3 is our equation, which does not have any more fractions in it, no more rational expressions. So 2x minus 12 minus, this x plus 2 should have parentheses because that minus sign is going to distribute. Minus x minus 2 equals 3. Combine like terms, 2x minus x, x minus 14 equals 3. Let's add 14 to both sides. That means x is equal to 17. This whole number 17, we're going to plug that in to our original equation. Let's copy it. Let's paste it here. And this is our check. And again, when you check, you're checking into the original equation, and we are replacing that variable x with our answer 17. So 17 minus 6 is equal to 11, so this is 11 over 3. 17 plus 2 is 19. So we're getting 11 over 3 minus 19 over 6 equals 1 over 2. We're going to have an LCD of 6. So that means this times 2, 22 over 6 minus 19 over 6 equals 1/2. 22 minus 19 is equal to 3. 3 over 6 reduces to 1/2. So then our answer is valid. X equals 17 is our answer to this equation. Number 3, we only have one single denominator here, and that denominator is equal to x minus 4, so that is our LCD. So whether the LCD matches or not, everything has to get multiplied by this LCD. No matter what, every single term, 1, 2, 3 of them in this case, are going to get multiplied. All right, so x minus 4s are going to cancel on here, here, and there, and there. So 2 times, not times, that's the only thing left is a 2. So 2 minus 4, which is multiplied by x minus 4, equals 6. And again, the x minus 4 is canceled out, so there's nothing left to multiply there. Negative 4 is going to distribute to get 2 minus 4x plus 16. And then we can solve this equation first by combining like terms. Negative 4x plus 18 is equal to 6. Subtract 18 from both sides. Negative 4x is equal to negative 12. Divide by negative 4, and we're going to get an answer of x equaling positive 3. So let's check and see whether this works. Once again, this is our original equation up here. So 2 over 3 minus 4 minus regular 4 equals 6 over 3 minus 4. And we are just working the left and right side out independently. 2 over negative 1 minus 4 is equal to 6 over negative 1. We're working out the left and right side independently to make sure that they match. We are not multiplying anything on both sides. We're not multiplying an LCD or anything. That's for equations. This is not an equation here. This is an evaluation. So negative 6 equals negative 6 means our answer, x equals 3, is good. So let's try this one. It's a little bit trickier. The reason why it's a little bit trickier is that our denominator can be factored so that we can identify the LCD as x times x minus 9. All right, so that's two separate factors, one x and one x minus 9. So 9 over x minus 9 is going to get multiplied here. 81 over x times x minus 9 is going to get multiplied here. Once again, everything is going to get multiplied no matter what. All right, this isn't one of those cases where you are trying to make denominators match. We're just multiplying everything by this LCD. X times x minus 9 cancels out. X minus 9 cancels out here. So we're left with 9x minus 81 equals negative 1 times x minus 9. Let's look at this one here. 9x minus 81 equals negative x times x minus 9. That's multiplying negative 1 times x first. 9x minus 81 is equal to negative x squared plus 9x. That is distributing this negative x. So what can we do now? This is a quadratic equation. Quadratic equation must be set equal to 0. So we'll do that by adding x squared and subtracting 9x to both sides. Adding x squared will make this quadratic to be positive. If we line up our like terms, like so, this actually adds up to 0, 9x minus 9x. So we get x squared minus 81 is equal to 0, which can be solved by adding 81 to both sides and using the square root property, or it can be solved by factoring using the difference of perfect squares. Zero product rule, right? We get x plus 9x minus 9, and the zero product rule, subtract 9 from both sides, x is equal to negative 9. Add 9 to both sides, x is equal to 9. We got two answers, which means we have two checks. So if we check x equals 9, first of all, this is our original equation, so 9 over 9 minus 9. The 9s that are getting plugged in, we're putting in parentheses. 9 squared minus 9 times 9, 81 up top. This is equal to negative 1. We'll see if this works out. So 9 over 0 minus 81 over here, which turns out to be 81 minus 81, which is 0, is negative 1. This, we can stop right here, because this is where we reject an answer. If an answer gives a denominator of 0, that means that this number here is undefined, which means that 9 is not a valid answer, so we're going to reject it. Now let's go ahead, because that does not mean the other one is not going to work. We can plug in negative 9 and see if it works out. 81 up top, negative 1 on the right, and we're going to work this out and see if it adds up. 9 over negative 18 minus, this is going to be 81 plus 81, that's 81 over 162. And this is equal to negative 1. So let's see, this can reduce to negative 1 over 2. 81 over 162 also reduces to 1 over 2. So negative 1/2 minus 1/2 is going to add up to negative 2 over 2, which is equal to negative 1. And negative 1 on the left and right side are the same. So this answer of x equals negative 9 works, and x equals 9, positive 9 did.